Good evening, good evening. How's everybody doing this evening?
All right, how you doing?
Doing well, doing well. Listen, I got, I've going into the holiday, got several people emailing me or I'm talking to people getting ready to take their exam, and I was sent this image. It was a practice test or something like that. I don't know, but this is one of the most commonly missed questions on the exam. And it may be the easiest problem on the exam. So first, let's start there. So it's only two people this evening. Tell me what you think the answer would be. So it says add one number to each column of the table set that shows a function. So first of all, that don't even make sense. Add one number to each column. There's only one column that's empty, but anyway. Do not repeat an order pair that is in the table. Click on the numbers that you want to select. Click on the numbers. There's only one cell available. But anyway, we're not going to go into the grammatical part of it. But click on the number you want to select and drag them into the table. So they make it seem like you have more than one, right? Well, maybe it is. Maybe this is maybe both of these are supposed to be empty. So that's what I'm thinking. So maybe this is supposed to be empty.
Mhm.
Okay. What two numbers do you think we could put there to make this show a function? So I'm gonna ask each of you, what numbers do you think you could put there? Let me ask this question first. Do you have any idea how you would do this problem?
No, I wouldn't. I would want to go from the beginning, Professor Tinsley.
Okay. How about you, Asma?
It's like we say y equal x. X should have a number plus another number.
Right. So what two numbers can I drag into these two open spaces?
Mm,
Um,
I think
we do. Mm,
So
um,
so evidently you don't know, right?
That's no
Don't
problem.
yeah.
and listen, and don't worry about it because I'm about to show you. Now now remember how I prefaced this whole question. I said this is probably the easiest question on the test. And either of you knew how to do it, right? So you're probably thinking, Mr. Tinsley, you must be out of your mind. No way, this is the easiest question I'm about to show you. This is the key word you're looking for, function. So to make this a function, what you have to realize is what's the definition of a function, right? So one of the things you can remember is, I'm gonna write it down for you. For every x,
There's a Y.
no, there
Mm,
is only one y.
okay.
For every x, there's only one y. So when you look at this table, you see that this table is broken up into two columns, x and y. So x is our input, y is our output, all right? Okay, so Ms. Tinsey, I understand that. That's not hard, all right? But do you understand what that means? For every x, there's only one y. So when x is 6, y is 6. When x is 3, y is 8. When x is 9, y is 12. When x is 7, y is 8. So you're thinking it. What you're trying to do is you're trying to come up with an equation till you know what to put those two numbers in. That's what you're doing. I know that's what you're doing. You're trying to figure out what can I do to x to make x 6? If x is 6, how can I make y 6? And if x is 3, what can I do to make what? You're trying to figure out what this equation is. That's not what you're supposed to be doing. The key word is that status showed as a function. For every x, there's only one y. So we have several different pairs here. 1, 2, 3, 4. We already have 4 ordered pairs. So even though this is a table, this is the same as 6 comma 6. This is the same as 3 comma 8. This is the same as 9 comma 12. This is the same as 7 comma 8. So what happens is when you see ordered pair, people get a little confused because usually don't an ordered pair usually looks like that. But it's the same information shown in a different way. Oh, Mr. Tensley, I know what an ordered pair is, but they're asking about a function. What two numbers can we put there to make this a function? Okay. For every x, there's only one y. Okay. So if 6 is already here, can this number be 6? No,
Nope.
because for every x, when x is 6, so we put a 12 there. I have two different y's. So when you look at this problem, this is all you got to do. That last ordered pair, the x can't be 6. It can't be 3. It can't be 9. It can't be 7. So you could put either 8 or 12 here, and it doesn't matter what you put for y. For every x, there's only one y. So let's just put something there. Okay, so I'm gonna put 8 and I'm gonna put 12. For every x, there's only one y. When x is 6, there's only one y. When x is 3, there's only one y. When x is 9, there's only one y. When x is 7, there's only one y. When x is 8, there's only one y. That's why I say this is maybe the easiest problem on the exam. All you got to do is make sure your x's don't repeat. Now, in some cases where if your x does repeat, it would be the same thing. So if you had 6, 6, then that's the same point. X's are not repeating. For every x, there's only one y, still only one y. So, but what the important thing is you can't repeat in ordered pair. So that's how you know that value for x can't be a previous value of x. So it can't be 6, can't be 3, can't be 9, can't be 7. I could have put a 12 here. I could have put an 8 here. I could have put a 3 here. I could have put a 7. I could have put it doesn't matter what your y is as long as your x's don't repeat in this problem. Everybody understand that?
Yeah.
Easy problem. Literally, like if you see a problem like this, the key word you're looking for is a function. First thing you should be thinking, for every x, there's only one y. So it's only two things that you can think when you see a function anyway. For every x, there's only one y, or to evaluate the expression. So let me tell you what I mean by that. Again, um, functions um, are synonymous for our intents and purposes. Instead of f of x, you could say y. So for example, let me show you what I'm talking about. So for a linear equation, right? Hold on, if I can ever get to the problem. Matter of fact, let me just go really fast to the end. There we go, right there. Which table represents a function? So this is an example. Which table represents a function? When x is 0 here, you have two different y's. Remember, for every x, there's only one y. So when x is 0, I got two different y's. This is not a function. When x is 5, I got two different y's. Not a function. When x is minus 2, I have two different y's. Not a function. You have all different x's here. So people think because your y's are the same, this is not a function. No, for every x, there's only one y. So when x is minus 5, y is minus 4. When x is minus 4, y is minus 4. When x is minus 3, y is minus 2. When x is 0, y is minus 1. This is the table that represents a function. Easy problem. Now, the second thing you have to do with functions, evaluate it. It's just substituting. We have to evaluate a function. It's just substitution. So it just shows you a different way. So f of x, this is how you read that, f of x is equal to x squared minus 3/8. Find f when x is minus 8. So basically, when you see this, whatever's inside these parentheses is x. So basically, what it's saying is x is minus 8. And all you're going to do is plug minus 8 everywhere you see x. But this is the mistake that people make. So tell me if I'm right or wrong. So what I said was I'm going to put negative 8 everywhere x is. Is that correct? Did I put minus 8 everywhere x is? It sure seemed like it, right?
Yeah, it seemed like it.
This is actually wrong. I'm going to show you why.
The first one should be
Please excuse my dear Aunt Sally.
Right.
So this is minus 64. This is plus 24. Your answer here would be minus 40. This is the common mistake. This is why when you have to evaluate an expression, or if you have to evaluate an algebraic expression on the GED, almost every time the value is negative. They want to see if you're going to make a mistake. This is wrong. Hold on, Mr. Tinsley. You said, hold on, Mr. Tinsley. You said everywhere I see X, I'm going to put a negative 8. And that's what you did. So why is it wrong? Because you're squaring what X is. So what you have to do is put the minus 8 in parentheses. Then you're going to get minus 8 squared, which is minus 8 times minus 8, which is a positive 64. Two positives make a, two negatives make a positive. So your answer would be 88. Okay, hold on, Mr. Tinsley. I'm confused. I'm confused, Mr. Tinsley. I'm confused. I'm gonna make it simple for you. Minus 8 squared is negative 64. Negative 8 in parentheses squared is a positive 64. Okay. Now, third way, I'm gonna prove it to you. Hey, Mr. Tinsley, I don't believe you. I know I know you on here every Monday and I'm asking you all these questions. I don't believe you. Watch this. Minus 8 squared is minus 64. Minus 8 squared is positive 64. So, what I would recommend you doing, whether you have to evaluate an algebraic expression or you have to evaluate a function, this is what I would suggest you do. I need you to fully understand what I'm telling you right now. Watch this. I need you to take your calculator and I want you to go minus 8, store X. Press your enter, and then you plug this expression into your calculator exactly the way you see it. X squared minus 3x. I'm done, 88. Instead of you wasting time doing it by hand, you can use the TI-30XS Calculator to evaluate an expression or a function. Guarantee you're going to have 2 to 3 of them on your exam. Instead of wasting time and plugging numbers in and making sure your negative signs are right. And please excuse my dear Aunt Sally. Use your calculator. I can't tell you any other way. You would say you want to save a minute to 2 minutes on each of these problems. For example, let me show you another one. I've been working this week. I got calculus, pre-calculus. Mm, mm, mm. And I can't, I must have, it must be gone. I must have, you have so much stuff open, it pushed it down. That's my calculus, pre-calc, that's trigonometry. Where are you? Okay, I cannot find it. Let me see. See if I can find it this way. Okay, it's not. I cannot find it. I apologize. Okay, I can't find it. I apologize. So, I'm a do. Let me go to a blank page, and I'm gonna show you what they'll do. They might say, I'm just gonna make this up. Evaluate x squared minus 3x over 4 when x equal -3. Or they might say uh, a squared minus 4ab over minus 3b when a is 2, and again, I'm just making these numbers up, and b equal -4. So normally what you would have to do is plug these in, right? You plug -3 as x here, you put -3 here, and so you what they would, and they would have multiple choice for you to choose your answer. So they would have A is 0, B is 18 or 9, C is 18 over 4, D is minus 18. So the first thing you would do is, again, you have to plug these in. So most people make the mistake and go -3 squared minus 3 times 3 over 4. So you get -9 plus 9, 4, which is 0 over 4, which is 0. That is wrong. Okay, so remember, what did I just say? Please excuse my dear Aunt Sally. So if I'm using my exponents first and I'm squaring my number, I must put it in parentheses. Then I get 9 plus 9, 4, which is 18 over 4. And I didn't reduce it. I apologize, which is 9 over 2. Should have said 9 over 2. I apologize. But again, that's too many places you can make a mistake. So what I would suggest you do, let me clear it real quick. What I would suggest you do and it would be nice if I remember the problem x squared minus 3x over 4. What I would suggest you do is storing -3 is x, and then plugging it the way you see it. Hit ND, x squared minus 3x over 4. And then let me clear it so you can see the calculator nice and clear. We didn't do any work. All we did was learn how to store these numbers in a calculator. So this is one of the most important concepts in the book, in my ebook that I go over. Look at that, you're done. 5 seconds, 10 seconds at the most. On that second problem, let's look at that. Let's look at that. Because recently they have been putting two values for you to evaluate an expression or a function. I mean, for algebraic expression. Remember, this can be done to evaluate an expression. It can be also used to evaluate a function. In this case, we're going to evaluate an expression. We have two variables. So you grab your calculator, and my computer just froze. There we go. You grab your calculator and you store A is 2. So 2, store. You hit the variable button several times until you see A. You go hit enter. -4, you're going to hit the store button, and you're going to hit the variable button several times until you see B. Press enter. Then you're going to type that expression exactly the way you see it. ND, I'm going to hit the variable button until I get the A, squared, -4A, hit my right arrow, hit the variable button again until I get the B, over -3B, -3, then hit the variable button until you get the B. Now, I don't know what this answer is. I just made that expression up, but look at that. Done. Now, if we did this by hand, we would have to go A squared, which is 2 squared, -4, times A, which is 2, times B, which is -4, all over -3, times a -4. Right? So we get 4, a negative times a positive is a negative, and a negative times a negative is a positive. So that's +32 over +12. We get 36 over 12, and we get 3. What, isn't that what we got with the calculator? So again, learning how to store a variable on this calculator not only will benefit you to evaluate an expression or to evaluate a function, but also if you have multiple choice and you know the formula being used, you could also use the multiple choice to plug numbers in also. All right, so what questions do you have? I saw somebody just, let me see. What questions do you have um, that you want answered that you had troubles with working on this week? So what have you been working on that you need some assistance with?
Hello, Mr. Tinley.
How are you?
Okay.
Glad you could join us.
Yes. Mr. Tinley, you forgot to send me the code.
Oh, I sure did. You are 100% right. So what we'll do is after tonight's session, I'll log in and send you the code. So we won't hang up until I
The
send you
thing
the
is,
code.
I'm on my phone though.
That's okay. So you can either, what you can do is call me. Um,
I forgot your telephone number. I wrote it down, but I forgot it.
all right. So I'll finish this session and then I'll call you.
Okay. All right.
Oh,
Great.
okay.
Okay.
Bye-bye. All right. So is there anything that you've been working on this week that you need assistance with? Brandy, Asthma, anything you've been working on this week?
Hmm. I did just take a quiz sensitivity. I'm not sure which is the last one I did. I
Mm-hmm.
want to say it was, oh God, was it slow? I can't remember sensitivity, but I know that I said, oh, I got to go back over this one because, yeah, that score wasn't looking really good.
Who was it?
I want to say, Miss Professor Tiffy, I want to say it was slow, intercept
Slope,
form.
slope intercept form. Okay.
Yeah.
That's definitely gonna be in your exam. I can
Oh
almost guarantee. So let me see if I can find something real quick. Let's see. Mm, Let me see the chat. Let me see the chat. Algebra problem solving. Well, you have to be more specific than that because everything that you had to do in your exam, almost 60% of your exam is algebra. So what we just did was algebra, evaluating the functional, evaluating the algebraic expression. You could do the distributive property. You could solve one-step equation, two-step equation, multi-step. Linear equations is actually algebra. So if you could be more specific in what you meant, then I can definitely help you. But let's find some slope problems. Let's see.
I'll say some linear equations, Professor Tinsley.
Okay, now I definitely have linear equations ready to go. Let me find it real quick. Here we go. So this is a worksheet that I found on CUDA software. Um, I actually love it. Um, so somebody actually took the CUDA software and made it their own. It was on the internet. So this is a slope from a graph. This is slope from an equation. Slope from 2 points. Find the slope of a line that's parallel. Find the slope of a line that's perpendicular. Sketch the graph of each line. Write the slope-intercept form of equation of each line. And again, this review probably goes over find equation of a line given a point in a slope. Find equation of a line given 2 points. Find the equation of a line that's parallel or perpendicular to another line. So you might be saying, hold on, Mr. That's a whole lot of work. This is probably one of the most important worksheets that anybody is studying for the GED can have. Because linear equations with slope is probably anywhere from 5 to 10 questions on your exam. That's a lot of work. Okay. So what will I see, Mr. Tinsley? What type of questions will I see? Okay. So you definitely are going to have a problem like this. What is the equation of a line that passes through the points -3, -2, and 1, 6? So on the GED, they're either going to ask you the equation of a line from 2 points, or they're going to ask you the slope of a line from 2 points. You have to know how to do both. But I can almost guarantee it's going to be in your exam. Does anybody know how you would do this problem? Would anybody know how to do this problem? What is the equation of a line that passes through -3, -2, and 1, 6? Did anybody know how to do this problem? Okay, before we go there, let's see. Let me ask you a question. What is slope? Can anybody tell me what slope is? Because I'm asking you to do slope, but what is slope? Okay, so that's the first thing. Slope is just the steepness of a line, how steep a line is. So when you talk about linear equations, think about the word linear. What word is in linear? Line.
Mm.
So if you have a line, more than likely it's a linear equation, right? So don't get
Right.
all worked up about linear equations. It's just a line. So what would be the equation line? So here they said find the slope. So let me make this nice and big. Does anybody know how I'll find the slope of this graph? How would I find the slope of this graph? Okay. So first of all, you need to know the slope intercept form. Now, in this case, we're only finding the slope, but I just want you to know that y equal mx plus b, where m is your slope and b is your y-intercept. Hold on, Mr. Tinsley. You are talking another language to me right now. What are you talking about? So when you're learning something new, don't get inundated about new vocabulary, new terminology. Try to understand one thing at a time. first of all, we have to realize that slope is the steepness of a line. How? Well, again, the steepness is a number. So, for example, let me ask you a question. And this is just common sense, right? If I'm skiing, if I ski, right? Which one of these lines is the advanced slope? So I'm skiing down the ski slope, and I'm a beginner. Which slope? Let's call this one ski slope. If I'm a beginner, which slope should I be on?
Slope number 2.
Slope number 2. Why? Because if I go on slope number 1, it's going to pick up that acceleration is going to be too fast. I might crash into a tree. Same thing for a roof. So we see slope every day. So the reason why I would like to use that example is because everybody's familiar with a ski slope, right? All right, so that's to give you the visual. Okay, so we got the visual in our head, Mr. Tinsley. Now, how do I do it? So it's two ways you can find a slope, right? You can find it using 2 points, and I'm gonna show you both ways right here. So we can find a slope using 2 points, or we can find the slope of a graph using rise over run. Hold on, Mr. Tinsley. What are you talking about again? So rise, what direction is rise?
Upward.
Up.
Going up.
So if rise is up, if my rise is negative, what direction am I going? So if rise is going up, if my rise is negative, which way am I going if my rise is negative?
It's negative. You going downward?
Be going down. Okay. That's not hard, right? Okay. Run. Run is horizontal. So you run, you run on the horizontal, right? So
Right.
again, if we look at the graph, this is my y-axis, this is my x-axis, this is my positive, this is my negative, this is my positive, this is my negative. So as I go up, I'm going towards the plus side. That's rising up. If my rise is negative, I'm coming down. My run is to the right. That's positive. If I go to the left, my run is negative. So what I'm going to do is I'm going to start, and this is what I tell, it doesn't matter what points you use, but I always tell my students, start at the leftmost point. So which point is on the leftmost. So that's this point here. So next thing I tell them, from here, M equal rise over run. So rise, how many do I need to go up? 1, 2, 3, 4, 5, 6, 7, 8, 9. I know to stop when I reach my second point. So my rise for this problem is 9. My run, now I need to go to the right to get to my point. 1, 2, 3, 4. So my run is 4. So the slope of this line has to take into account the rise and the run of a line. So the slope of this line is 9 over 4. Well, what does that mean?
Mm.
Every time I go up 9 and I go over 4, I'm going to have a point on that line. Every time I go up 9 and I go over 4, I'm going to be on that line because the slope, it has a constant rate of change. So the slope of this line would be 9 over 4. Okay. So when I'm showing my students how to find slope from a graph, this is what I'm doing first. Math is about patterns. what you see over and over again. You just have to practice enough to commit it to know it, to commit it to memory and to know it, right? So the first thing we noticed that when my slope was 9/4, right, it was a positive slope. So what you should notice, or what you should take in mind, from left to right, if I'm going up, my slope is going to be negative. I mean positive. So from left to right, if I'm going up, from the leftmost point, if I'm going up, my slope is positive. The leftmost point. So in this case, my leftmost point is right there. But this time, to get to my second point, what direction am I going? Going down. So I know visually, I know right away my slope is negative. What, Mr. Tinsley, why is that important? Well, it's important because when you're in the GED, if they ask you, they give you a graph and they ask you about the slope, two of the answers are going to be positive, two of the answers are going to be negative for most intents and purposes. So you get to get rid of two of the answers right away by just looking at it. The next thing I want to show you is how to find the slope of this problem. Again, this is a graph. They are giving you 2 points. Now, I need you to understand there's more than 2 points on this line. That's a point right there. That's a point right there. That's a point right there. These are all points on a line. You can use any 2 points. Luckily, they gave us the points. We don't have any work to do. So the first thing you want to do is when you see that graph, you're going to see slope equal rise over run. If they want you to find the slope from a graph, you should be thinking rise over run. Second thing you should be doing, you want to go to the leftmost point, and you want to start from there. So if I start from my leftmost point, which is right here, in order to get to my second point, rise tells me I need to go up or down first. Well, if I go up, I'm never going to get to that second point. So I'm going down. 1, 2, 3, 4, 5, 6, 7. I went down 7. Because I went down 7, my rise is -7. My run, I now have to go to the right. 1, 2, 3, 4, 5, 6. My run is a +6. So my slope for this line is -7/6. That's how you find a slope from a graph. That's how you, so on the GED exam, you have to know how to find a slope from 2 points, slope from a graph, slope from an equation, slope from a table. Okay. So what we just did is we found how to, I just went over how to find a slope from a graph. Even though we have 2 points, we found a slope from the graph. Now, you also could say, okay, this is another guaranteed question in the exam. What is the location of my 2 points? So an ordered pair means my x is first, then my y. This is my x-axis. This is my y-axis. Again, this is another guaranteed question. What is the location of those 2 points on this coordinate plane? So I come down to my x first. So 0, 1, 2. So my first point has an x of 2. My y, I go over to my y. My y is 1, 2, 3, 4. So my ordered pair that identifies this point is not 2, 4. It's -2, 4. Hold on, Mr. Tippett. Why? Because this is 0. And remember, I told you, when this side of the x-axis is positive, this side of the x-axis is negative. So this point is -2, 4. Now, let's use this point. Again, let me use arrows here. Let me change it to arrows so we can see. We'll go from this point, I'll come up to my x-axis. What's my x? 1, 2, 3, 4. So for this point, my x is 4. What is my y? I go over to the y-axis. 1, 2, 3. Since I'm below the origin, again, this is my positive. This is my negative. So if I'm above my origin, it's positive. If I go below my origin, it's negative. If I go to the left of my origin, it's negative. If I go to the right of the origin, it's positive. So 1, 2, 3. So that's my second point. 4, -3. That's another guaranteed problem in your exam. Locate or identify a point on the coordinate plane. Well, Mr. Tinsley, how are we going to find the slope from that? Okay, so we got our 2 points. Let me write them down. -2, 4, and 4, -3. Now, I believe we already found out what it was because we did rise over 1. We said 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. We said our slope. Remember what we said. We said our slope was -7/6. That was easy. Visually, I can count down, up or down. I can count over. That's not a hard problem. But on the formula sheet, if they give you 2 points, they want you to do this. Not if they give you a graph, but if they give you 2 points. On your formula sheet, you will have a formula that says m equal y2 minus y1 over x2 minus x1. I'm going to show you how much harder this is finding the slope from a graph. I'm going to show you. So this is my first point, so I'm going to call this x1. This is my first point, so I'm going to call this y1. This is my second point, so I'm going to call this x2. And I'm going to call this y2. Now all I'll do is plug in. My y2 is -3 minus my y1 is 4. My x2 is 4 minus my x1 is -2. If you don't know by now, 2 negatives make more negatives. So -3 minus 4 is a -7. 4 minus a -2 is 4 plus 2. Did we get the same exact slope? Yes, we did. But look how much longer the second one took us. Look how much longer the second one took us. So if you have if they ask you to find a slope from a graph using rise over 1, they give you 2 points. You got to plug into this formula that's on your formula sheet. You should know this formula like the back of your hand. So that's it. So I gave you 3 questions. I gave you 5 questions. That's guaranteed in the exam. Okay. So, all right. So let me go back to my review sheet. And I lost it, didn't I? There we go. The second way you should know how to find the slope is from an equation. So let me make this bigger. Again, another easy problem. Y equal mx plus b. To find the slope, whatever in front of x. Whatever's left, if it's in this form, is your y-intercept. So my slope is -5. That easy. You get an equation, and it's in the form of y equal mx plus b. Now, I didn't say 2x plus 3y equal 9. That doesn't look like y equal mx plus b. They are not the same form. It should start with y equals some coefficient, your variable x, then some constant. You can easily tell. That's why it's called slope-intercept form, because you can easily get the slope and y-intercept right away. You should be able to look at it and get the slope. So let's see if we can get it. For number 6, what would the slope be for number 6?
Negative 1/2.
Negative 1/2. Because this linear equation is already in slope-intercept form. So the slope of number 8 would be what? Will be the slope of number 8.
-5/3.
Slope is -5/3. That's all you have to do if you're given an equation in slope-intercept form. Now again, I already showed you how to find the slope of 2 points. y2 minus y1 over x2 minus x1. These are 2 other problems. So you might be thinking, oh my goodness, Mr. Tins, this is a whole lot. So what you're going to do is, whether you use my YouTube channel or use this videos tonight, you go over the problem or problems until you got it. Don't move on until you got it. Especially if I'm telling you these are guaranteed problems on your exam. Okay. So it says find the slope of a line parallel. What does parallel lines mean? What does parallel mean?
2 lines that never cross
Lines
or
that will
intersect.
never cross. You're 100% right. Lines that will never cross. Now, if you notice, what does slope mean? So if I had a slope of 3 halves, right? And I'm just going to draw this, you know, freehand, right? It's saying every time I go up 3, and it's not the scale. Every time I go up 3, 1, 2, 3 over 2. 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 That's what the slope means. For every 3 that you rise up, you're going to go over 2. So if 2 lines never cross, that means they have the same exact slope. That don't mean that they're the same exact line. That means they have the same exact slope. So let's look at it again. So if I'm giving you this equation, and this is y, and this is in slope-intercept form, and I know what's ever in front of my x is my slope. What's my slope for number 13? What is my slope for number 13?
2/3.
2/3. So any line parallel to that line is also the slope is going to be what?
2/3.
2/3. Hold on, Mr. Oh my goodness, Mr. Tins, you are blowing my brain away. This is what you got to remember. This equation is y equal 2/3 x minus 2. An equation that's parallel to this, an example, would be y equal 2/3 x plus 10. Y equal 2/3 x minus 5. They all have the same slope of 2/3. The y-intercept is different, so they're not the same line, but they will never cross. So I'm going to prove it to you. I'm going to open up one of the best programs out there today. It's called Decimals. And Decimals is a graphing, program. And watch this. I'm going to prove it to you that parallel lines have the same slope. I'm going to prove it to you. Watch this. Y equal 2/3 x, I think it was -5. Y equal 2/3 x. Y equal 2/3 x plus 3. What you should notice is, look at these lines. They never cross. Ever, 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 ever. They will go on to infinity and they will never cross. Why? Because their slopes are the same. So not only did I say it, not only did I show you, but I also demonstrated and graphed it for you so you can see that parallel lines have the same slope. So if they tell you something is so if I said slope of a line is 5/2, I know my equation is going to start with y equal 5/2 x. Anything parallel to that? Y equal 5/2 x minus 3. Y equal 5/2 x plus 2. Doesn't matter. The slope of each of these lines is 5/2. The slope of each of these lines is 2/3. These are parallel lines. Everybody understand that? Okay. So for number 14, what's my slope of number 14? What's my slope for number 14? What's my slope for number 14? Anybody, it doesn't matter.
9/5.
9/5. The slope of any line parallel to this line is also what?
9/5.
That easy. So again, if you're not sure, and that's the reason why you're not answering, then watch over this video to make sure you understand. Listen, you should not be afraid to make mistakes. This is the place where if you answer incorrectly, it doesn't cost you anything. If you get it wrong on a GED exam, you're going to be frustrated, you're going to be upset, and you're going to be mad. So here, I want participation. So if you do make a mistake, I can fix your mistake. You can fix your mistake, or we can fix your mistake, and then we can understand why we made that mistake. But you cannot, especially in this environment, you cannot be scared to say and answer what you think it is. If you're wrong, we can correct it. Because but guess in real life, we learn our biggest lessons from our mistakes. Just think about life. We learn more from our mistakes than we do when everything is peaches and cream. So I want you, so it's almost 7 o'clock. And then this is the last thing I'm gonna do for a perpendicular line. Okay, so we said parallel lines are two lines that will never cross. Well, perpendicular lines are lines that will cross and they form a 90-degree angle. Not only will they intersect, but what's special about perpendicular line is that they will intersect or they will cross and they will form a 90-degree angle. Almost everything you can look around, you will see a 90-degree angle everywhere. Your table, your walls, 90-degree angles are everywhere. Okay. So I'm looking at number 15. My slope is -1/2. My slope of any line parallel to this line is also -1/2. To find the slope of a line that's perpendicular, you take the negative inverse. Oh, Mr. Tenzi, what does that mean? That negative M? Oh my goodness, I don't know what that means. I'm gonna make it simple for you. Once you find a slope of a line, to find any line that's perpendicular to that, you change the sign and you flip it. So the slope of this line was -1/2. So change the sign, means it's going to change the positive, and I'm going to flip it. Instead of 1/2, I'm going to have 2/1, which is 2. So the slope of a line that's perpendicular to this is 2. An example of a linear equation that has a slope of 2 is y equal 2x plus 3. Y equal 2x minus 5. Y equal 2x plus 1.2. I don't know. But the key is that the slope is 2. These all have a slope of 2. So I hope that helped you tonight. We found a slope from 2 points. We found a slope from a graph. We found a slope from an equation, slope-intercept form. And we found the slope of a line that's parallel. And we found the slope of a line that's perpendicular. Okay, you can use this video. You can use my other YouTube videos. But this is an area I can almost guarantee you're going to see every one of these problems on your exam. Any questions before we leave this evening? Okay, it was a pleasure. I will see you next week. Make sure you have your questions ready. And next week, I'm calling on people. Everybody have a wonderful night.
You too.
Thank you. I'm gonna stop the recording.